Why, hello, math students. I thought I'd start off today's lesson of solving radical equations with a little comic here. Hope you all understand it. If you don't, the blue guy's imaginary because he's a square root of a negative number. All right, today's lesson is solving radical equations. Again, our entire goal in algebra is to get x by itself. So right now this equation is being cubed rooted. So we want to undo that. We want to do the inverse operation. So we want to cube both sides. When you cube a cube root, they cancel each other out and we're left with what's underneath the root to begin with. So 2x plus 7 and then equals 3 cubed is 27. And now it's just solving a basic algebra equation. We're going to subtract 7 to both sides. Subtract 7. We end up with 2x equals 20. And then divide both sides by 2. So x equals 10. And you think you're done, but we're not done yet. Whenever we have root equations, we need to go back and plug in our answer that we got back up into the original equation to see if it works out, because it won't always work out. So we're going to plug this 10 back into the original equation. So we have the cubed root of 2 times 10 plus 7 equals 3. Cubed root of 2 times 10 is 20. 20 plus 7 is 27 equals 3. The cubed root of 27 is 3. So then we need to ask ourselves, does 3 equal 3? Yes. Yes, it does. So that means that our answer is x equals 10. Next problem is the square root of x plus 25 equals 4. So hit pause, see if you guys can try this one on your own. Welcome back. Because this is being square rooted, we want to square both sides to do the inverse operation. So we are left with, on the left-hand side, x plus 25. On the right-hand side, 4 squared is 16. We want to subtract 25 to both sides. We are left with x equals negative 9. You think you're done, but are you done? No, we're not done yet, because now we have to, that's right, go back and check it. So we plug negative 9 back into the original equation. So we have negative 9 plus 25, and then equals 4. Negative 9 plus 25 is 16. So we have the square root of 16. And the square root of 16 is, yes, that's right, 4. And you ask yourself, does 4 equal 4? And you answer yourself saying, yes, 4 does equal 4. So that means that x equals negative 9. Next problem. We have 2 times the cubed root of x minus 3 equals 4. Now, you got to do something else, or you got to do something first before you do anything else in this problem. And what does that you ask? Why? You need to divide both sides by 2. That's what you do. So divide both sides by 2. So we have the cubed root of x minus 3 equals 2. Now, how do we undo a cube root? You do the inverse operation. You cube both sides. You cube a cube root, it goes away. You're left with x minus 3. On the right-hand side, you do 2 cubed. 2 cubed is 8. We're going to add 3 to both sides. X equals 11. Are we done? Are we done? Are we done? No, we are not done. We need to go back and check ourselves. So you go back to the original equation and check your work. (11 minus 3 is 8. The cube root of 8 is 2. 2 times 2 is 4. And does 4 equal 4? Yes. Yes, it does. So that means that x equals 11. Okay, now we're going to step it up a notch here, and we're going to show roots in a slightly different way with fractional exponents. Our first step is we need to get the variable by itself, so we're going to divide both sides by 4. So we have x to the 3 halves equals 27. Now we need to remember, what does this fractional exponent mean? Well, the denominator of the exponent, this 2 here, that means the square root. And we want to reverse the square root. And how do we reverse the square root? By squaring it. And then this 3 here, that means we're cubing the x. And how do you reverse cubing? You cube root it, and the roots are on the bottom of the fractions. Another way to think of this is just putting this term, the x to the 3/2, to the power of the reciprocal of what exponent is there. So we have a 3/2 here, so we're going to put it to the power of 2/3. Because when we have a power to a power, what do? That's right, we multiply them. And 3/2 times 2/3 is just 1. So this leaves us with an x with an exponent of 1. And then we're going to do this to the 27. And 27 to the 2/3, the cubed root of 27 is 3. 3 squared is 9. And then are we done? Nope, not quite yet, because yes, that's right. We go back and we check ourselves. So we have 4. 9 to the 3/2 equals 108. And now we do 4 times. What is 9 to the 3/2 power, you ask yourself? Well, it's the square root of 9 is 3. 3 cubed is 27. And then 4 times 27 is 108. And does 108 equal 108? Yes. Yes, it does. So x equals 9. Okay, the next one, take a step or pause and then try this problem on your own, and then come back and check the answer. Okay, you should be done by now. We're going to go through this problem. You start off with the red, the steps here in red, and you add 1 to both sides to isolate the radical by itself. So then we're left with x plus 2 to the 3/4 power equals 8. Now we do the step in blue, where we do each side to the power of 4/3, which is the reciprocal of the original exponent. So on the left-hand side, we're left with x plus 2. On the right-hand side, we do 8 to the 4/3 power. If you cannot do this in your head, you can do it in your calculator. You would use 8 and then the caret key, and the caret key is the little button that looks like that. And then you would put 4/3 in your calculator, but be super, super duper careful. You need to put 4 divided by 3 in parentheses. You need to make sure that's in parentheses. Otherwise, the calculator will not perform the operation as you would like it to. So 8 to the 4/3 power is 16. So then in blue here, we have x plus 2 equals 16. We subtract 2 to both sides to solve for x, and x equals 14. Are we done? You should know by now. We are not done yet. We are now going to take that in and check our work. So we have 14 plus 2 to the 3/4 power minus 1 equals 7. Now the following question came up in my class today, and someone added 1 to the other side during their check. You really don't need to do that. We want you to keep everything that's on the left-hand side during your check, and everything that's on the right-hand side during your check. You don't want to be moving things back and forth during your checking process. So here we have 14 plus 2 is 16 to the 3/4 power minus 1 equals 7. 16 to the 3/4 power would then be 8. 8 minus 1. 8 minus 1 is 7. And does 7 equal 7? Yes. Yes, it does. So that means our original answer of x equals 14 is true. Now at this point you're probably thinking, but Miss Teal, do they always work out? No, they don't. So for this one, let's give this one a try and see if this one works out. Okay, so on this side, the left-hand side is being square rooted. So in order to get rid of that, we want to do the inverse operation. We want to square both sides. So we're left with 7x plus 15 equals, now we're going to do the math F word. I don't know about you, but we can't use this math F word in my school. We need to use the technical term. So we're going to do multiplying binomials. If you're thinking about what the math word is, I'm not allowed to say it, but I can spell it. You can do that process if you know that mnemonic device. Otherwise, we're multiplying binomials. So we take x times x is x squared. X times 1 is 1x. 1 times x is 1x. And then 1 times 1 is 1. Now we want to get all the terms to one side where the x squared is positive. That's going to make it the easiest to go on from here. So in this case, we're going to move everything to the right-hand side. So we're going to subtract 7x to both sides, subtract 15 to both sides of the equation. On the left-hand side, these cancel out, and we're left with x squared, and then we have x, and negative 7x. We combine all those together, and we end up with negative 5x, and then positive 1 and negative 15 is negative 14. And you think, oh my Lord, that doesn't look very simplified. What do we do from here? Well, there's two options you can do from here. You can do the quadratic formula, which, if you remember, is opposite of b plus or minus the square root of b squared minus 4ac all over 2a quadratic formula. But that's a bit of overkill in this case. You don't really need to do the quadratic formula. This is a basic factoring problem. And in factoring, we want to find the numbers that multiply to be the last number and add to be the middle number. So I'm going to go off to the side. We have negative 14. Well, what numbers multiply to be negative 14? Well, we have 1 and 14 and 2 and 7. Now, because they need to multiply to be a negative, that means one of our numbers needs to be positive and one of our numbers needs to be negative. They have to add to be a negative 5, so that means the bigger number needs to be negative, so it's a negative 7. So we're going to use the numbers 2 and negative 7. So we have 0 equals x plus 2, x minus 7. Okay, we're almost done, but not quite yet. We're going to set each of these parentheses equal to 0 to solve for x. So we're going to do x plus 2 equals 0, x minus 7 equals 0. So x equals negative 2, x equals positive 7. But don't circle your answers yet. Why? Why should we not circle our answers yet? Oh, that's right. We got to go back and check ourselves. So we're going to plug negative 2 into the original equation in both places for x. So we're going to have the square root of 7 times negative 2 plus 15 equals negative 2 plus 1. Over here on the left, 7 times negative 2 is negative 14, and then plus 15. Negative 14 plus 15 is positive 1, and then the square root of positive 1 is 1. On the left-hand side, negative 2 plus 1 is negative 1. So does 1 equal negative 1? No, it does not equal each other. So these are not equal. So that means negative 2 is not an answer, not possible. But let's try out 7, because 7 might still work. So we're going to have the square root of 7 times 7 plus 15 equals 7 plus 1. 7 times 7 is 49 plus 15. 49 plus 15 is 64. Square root of 64 is 8. On the right-hand side, 7 plus 1 is 8. And does 8 equal 8? Why, yes. Yes, it does. So that means our answer is x equals 7. Now, you can have problems where both of the answers work. So give this one a try. 10x plus 9 equals x plus 3. This one's a little funkified, but you can get the answer. I have faith in you. So hit pause and give it a try. Okay, so I'm running out of time, so we're going to go through this quickly. Hopefully you should be able to get to this point in green where we have 0 equals x squared minus 4x. At this point, you should, be thinking, oh my God, they have something in common. We can factor out the greatest common factor. And that is exactly what we are supposed to do. We're going to take an x out of both of them. After you take an x out of both of them, we're left with x minus 4. And then solve both of them for x. So x equals 0, and then x equals 4, and then go back and check it. Hopefully you understand solving radical equations. Have a good night. Bye.